For the people who do know it, would you like to come up and show the class? It's an opportunity to share your knowledge. You get extra marks on your sack.
I don't know how to do it.
Muskan? No? Aisha? You look like you know how to do it. You can do it. Let me give it a try.
Can I just say it like this?
Yeah, okay. You can sit there and say and tell.
Just part A.
Yep. Give me one moment while I pull up the question.
We already did part A though.
Was it part...
It was part B. We already know how to do part B.
This was a particular question, is that correct? Alright, what's your logic?
20.
Walk us through it.
Use AI.
AI.
Yeah, use them.
Okay. And then, what did you find out?
It's 6 choose 3
Why?
because first group is we choose 3 and then automatically the other 3 is going to be in another group. So we do 6 choose 3 and then you divide that. That's going to be 20 and then you divide that by 2 because you can get A, B, C for the first group or you could also get D, E, F. So that's why it can change. So that's why you divide by 2. That's what I'm saying.
So, the remaining 3 go into group 2?
Mm-hmm.
And so you said 6 choose 3 is equal to
20.
20?
But then, so let's say these 6 represent 6 different letters.
Mm-hmm.
A, B, C, D, E, F. A, B, C can be in the first group or the second one. Same for D, E, F. So that's why you have to divide by 2.
And so the only thing you're really focusing on is rearranging these values, is that correct?
And then that's how you divide by 2.
Okay. What if it was 4 choose 3? Can someone find out what 4... No, wait. That doesn't work. It's not 4 choose 3, is it? Never mind. Yeah. I was thinking about it in a different way. No. Yep. That's equal to 20, so then you would half it?
A, B, C can be in the first group or the second group.
A, B, C can be in the first group or the second group. But, yeah, the idea was that it would just be A, B, C over here, and then the remaining would be in the other group, though, right? What if they made a mistake? What if the answer was just 20, though?
But the AI said it was 10 as well.
Oh, okay. Is that because someone corrected it beforehand, before you asked the question?
Maybe the book's wrong. So you've got to call Cam. Let's call the author.
Yeah, maybe you gotta...
Is it multiple, yeah? Multiple.
I'll think about it and I'll write down all the possible combinations for it. Okay. How many ways can a group of 6 people be divided into 2 groups?
It's this guy.
What's the
12 question?
What's 6 choose 2?
6 choose 2.
Because there's only 12 versions. That's chapter 10C.
It's 15.
Ah, okay. That wouldn't work. What about if it was uneven or 2 unequal groups?
There must be at least one person in there. Doesn't it show you how to do it?
I'm curious.
No.
Yeah, is there work solutions for it? Did you check out the work solutions?
No, it's just 10.
No, here, what company?
Hey, what is that one website that you want to search up and ask questions on it? Tells you how to.
ChatGPT.
No. Is it Brainly?
Sorry? My parent?
Pen.
Oh yeah, what about it?
Mm.
Depends on the person that uses
That's
it.
2 equal groups, right? What if it was uneven groups?
Fancy.
Did you manage to answer part B?
What does it say?
1, 5.
Then here comes 4, yeah? 4 factorial, yeah?
4. I think so. So,
It says 2 equal
So this, I'm doing this.
Mm.
right there.
I'm doing
just-
this.
They just
Divided by 2.
Yeah.
Okay.
No, you can't do this.
So it becomes
Three
this.
divided by 2.
So it becomes 6.
Do the formula for it, it's easier. 2 equal groups, 6, 3,
Yeah, I was
2.
right.
Let me just do it.
2.
2 factorial, and 4 plus 6 minus 3.
What was this?
It's okay.
6 times 5.
I don't know.
Can we just skip this?
You can't skip something when it gets too hard.
We don't need. I'm gonna get it.
What about for part B though? What about 2 unequal groups? So let's talk through it logically, right? We've got 6 people. We want to choose them for 2 groups, right? How many people would be in the first group?
Oh, so 2 groups will
Doesn't
come
matter,
2 and
it could be 1 to
4 and 2,
6.
yeah? Is that what you mean?
1 or 5.
Or 2 and 4?
Another, yeah, or
2 or
Well,
4.
that's what I'm saying. Okay. That's what I'm going.
2 or 4.
Unequal. The first one is
But do you
equal,
want
so
3 3 though?
Oh, so it has
to be different numbers.
Yeah.
No, you don't want it to be
And then-
3.
And then 4 2 and then 5 1.
they have to.
So you have 6 people, and if you choose which one's easier to pick out for? 5 to pick out 5, or is it easier to pick out just one person and just put them aside, and
One
you've
person.
automatically got your 2 groups? All right. So for this segment here, it would just be 6 choose 1 for that particular combination
Plus
times.
plus
I think it would be
Oh.
plus, but
6 choose 2. Yeah. Does that become 6 choose 5?
yeah, for group 1 and group 2, it's like males and females, yeah.
You told me in the 2 equal groups is divided by 2.
What the?
So like we could arrange it. You have to divide this by like something as well.
Wait, hold on. I don't know yet.
Oh no, never mind.
Wait, hold on.
Isn't it 6? 5. Oh, so you already took out 1, yeah?
Yeah, because you already chose one person, right? So here, if you choose 2 people, how many people do you have left?
4
So you have 4 people. You choose
out of 4?
4 of them, right? That's why it ends up being 1. It doesn't matter.
Yeah, which chapter is that?
Sorry.
10
Yeah.
Selection or combination.
Likewise, if you have 6 people, you choose 5 of them. Then how many people do you have left to choose from? 1. Or if you have 6 people, you choose 4 of them. How many people do you have left to choose? 2 out of the 6, right?
That's
Then
right.
you just
You just end up
simplify it.
choosing them.
That's the right answer.
It's
What is?
21.
That's right.
For which one?
The bottom.
The bottom one.
Equals right.
It's 20. That's 21.
Yeah, 21. Yes.
Yeah.
6 of 1.
I wonder if this here would give us the same answer.
6 of 5.
It has to be then, yeah?
Yeah, but it's the same thing. The first one equals 6. And the second one, 6 of 4, 430
Yeah, the same answer.
It is the same answer.
What's
Right.
6? Wait, what's 6 of 4?
Huh?
Hmm?
What's 6 choose 4 equal?
Uh,
So
fif-
just 30. 4 and 6.
No, it's not 15. Is that 15? 15.
Yeah, 15.
Because you divide by 2.
You divide by, yeah.
Oops.
Why divide by 2?
Because
There'll be 2
left.
factorial at the bottom.
2 factorial.
And 2 times 1 is
Just
just
4
2.
Guys, can you have a look at this one here? We've just explained some logic here
Yeah.
for the unequal groups question, right? So if we have 6 people, we divide them into 2 unequal groups. There's 2 ways to look at it, right? if you have 6 people, you choose one person for the first group, right? So this position here is going to be group 1. This position here is group 2. Right? But then you have another way of picking the people. You can choose 2 people for the first group. I'm just going to look at this part here, and I'll go through and I'll explain. And likewise for this section here, you can also choose it like that for group 2. Now, if we just look at this top half here, if we just look at this section here, this top section, if you have 6 people, you choose one person. They have to be unequal groups, right? So in group 1 and group 2, it has to be unbalanced. Otherwise, if you choose 3 people in one group and 3 people in the other group, that's not answering this particular question. We want uneven groups, yeah? So if you have 6 people, you choose one person, right? After that, how many people do you have left to choose from the second group? If you've already chosen one person, you have 5 people left, right? And how many people do you want in that second group? 5. Okay, so you can see why we have 5 choose 5 here, which equals to 1. Okay? Or another way of organizing or picking the people is for 2 people to be in the first group, right? And 4 people to be in the second one. So let's say you choose and you prioritize, you pick these 2 people from the 6 people. Okay, you're going to be in group 1. How many people do you have left to choose from? You have 4 people left to choose from. And to make the second group, right? So it's okay, I pick up those 4 people and I'm going to say, okay, you're going to become group 2. So how many did you choose?
4.
You had 4 people left and you chose all 4 of them to make the second group. Now, that's one way of doing it, but the reverse is that if you decide to choose 5 people first, right? And you're just going to leave one person standing there left over. So it's like, okay, 1, 2, 3, 4, 5 people, you come with me, you become group 1. How many people's left standing in the corner?
1.
Okay, 1 person, and then that one single person will become group 2. Okay, that's one way of doing it. Or you can choose 4 people. Then there's 2 people left over. You're going to choose both of them to make the second group, right? Both of them should give us the same answer, but the question is why? Let's extend it a little. Why does it give us the same answer? If you run the calculation, you'll see that both of them come to the number of
Isn't that 6 times 2 equals
21.
Isn't like this? Look.
Does it equal 21?
Yeah, 21, but
Yeah?
isn't like this?
So why did those answers both give us 21? What principle can we draw upon?
In
Is it the same as
the
this?
first group here,
Is
the
it
top
the same
one,
as this, yeah?
the top one is 6 over
Mm?
1 and 5. No, not 1 and then that, the expansion
Isn't
one,
that
5.
Right, so
The
you're explaining it
bottom
from an algebraic
and the
perspective,
bottom one is the
right?
exact same thing.
Oh. Because
Yeah.
there's 1 in each one.
Yeah, there's a 1 and a 5 in both of them on the denominator.
Right, but what about these ones though?
They're
I don't
one.
want it. I just yeah,
No,
multiplying.
No,
Yeah.
that's the 1, because
No,
5,
but
5
it's
is 1.
also they could pick 6 people.
Oh.
No, they could pick 1 person for the first time, and they could pick 5
So,
people.
I want you to draw a concept that we talked about.
The triangle.
The one.
what triangle?
What triangle?
Oh,
Who?
oh yeah.
That triangle.
It's Pascal.
It's palindrome. Yes, it's a palindrome. So I'm gonna draw all the way to 6 levels. 'cause we do- 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. Have a look at where 6 choose 1 is. That's 6 choose 0. This here is 6 choose 1. Right? That is the same as 6 choose 5. Is it not?
Yeah.
Yeah.
0, 1, 2, 3, 4, 5. 6 choose 1 and 6 choose 5 give us the same values, right? What about 5 choose 5? Where's that? Row 5. 0, 1, 2, 3, 4, 5. Yes, so this here is 5 choose 5. And that there is 5 choose 5, yeah? Oh, it's 5 choose 0.
How do you get that?
Wait, what?
How did you get 6 choose 5 on the bottom one?
Because it's 0, 1, 2, 3, 4, 5.
For this one?
No, in the triangle.
Or for this one? This is 6 choose 0 here. This is 6 choose 1. This is 6 choose 2. 6 choose 3. 6 choose 4. And that's 6 choose 6. Yeah, that's why I'm saying like it's palingenomic, yeah, in its behavior. It's a mirror reflection. Yeah. So what number you choose on this end is equal to the number you choose on this end. But that 5 choose 0 there doesn't really matter, does it? What's 1? We're comparing that with 1 choose 1. What's 1 choose 1? Yeah, that's up here, yeah? 1 choose 1. Okay, I'm going to write that in the same color. Where's 6 choose 2?
Yeah, 15.
6 choose 2.
So
Okay,
where's 1 choose 0? And for
1 choose 0 would end up being the same one anyway,
Wow.
I think.
It's flawed.
Yeah, it's kind of broken. Or maybe the top one is actually a 1 and a 1. That's how we get the 2 there. Hold on. Pascal's triangle is incomplete.
Yeah, it should be like that.
Yeah, there it
No,
is.
without the top one.
No, why not?
Is it with the top one?
yeah,
I
how
don't
do
know.
you get
Yeah, true.
There it is.
So it's a pyramid. Pascal's pyramid because it's not a triangle.
Yeah.
Who's Pascal? I only have a look.
Pascal. Pastel.
the-
Faber-Castell.
Are you approving?
So that's 6 choose 2 there. Where's 6 choose 4? What value is it?
What?
You can see it's reflected, yeah? Same values. Yar? And 4 choose 4.
Huh? Because
There's a
it
one
has
at the top.
green hands.
There is a 1. And that should be 0 choose 0, yeah?
Yeah, 0 choose 0.
Okay. You know I'm recording this, guys, so it's all going on YouTube.
Yes.
Keep going.
Hi guys. Welcome to my vlog. It's not me. It was you guys. Andreas said that. Andreas was saying the truth.
So, if we answered that question correctly, can't we go back to this and say, okay, from group 1, I want 3 people. And for group 2, I want 3 people as well. Is there an alternative here to choosing 3 people?
Is that for A?
3 and 3 again.
Yeah, this is for part A.
I think that's it, yeah?
Right, so shouldn't it be 6 choose 3?
And 3, 2. Well, that equals 20.
But then,
3, 3?
how? Yeah, 3, 3. So that's 20 times 1.
You took out 3, so 3 guys left. 3 people left.
Politically correct. That's a success pass.
It's 21.
No, it's A.
Yeah, that's what I put in the calculator. 21.
Right, 6 choose 3 times 3 choose 3. I am still led to believe that there are 20 different ways that you can choose these groups.
Why don't we just find out?
Call them up.
Or people,
Just
because
find
you
out,
need people.
choose 6 people and suss it out.
Yeah, you choose
1,
people.
2, 3,
So like
4,
A,
5,
B, C,
6.
D, E, F.
1,
G.
2, 3, 4, 5, 6. It's like an experiment and then we're trying to test out the theory.
Can we go to 11B?
Yeah, but you just choose the 3 people. The 3 people that are left over become the second group.
Do you want to do it now?
Okay, so they're gonna be one group.
We're going to be here for a while, and
Maybe a group with a teacher.
I don't think we're going to... Yeah.
And then it can be Aspak. And then it can be her, then it can be me, and Anajan, and then you 3.
We're going to lose track. Do it in your own time.
No, but
I'm fine.
Yeah. I'm going to move... Any other questions?
11.
Yes.
20.
10D. So we're still addressing chapter 10.
Yes, chapter 10 is annoying.
Which question? 8. 10D.
That's 10C.
10C.
So will there be a pseudo-coding question in the hurdle?
Nope.
do it for you.
What about the sack?
Nope. Just for you, alright, man.
So Andreas, what's his last name? Starts with K. I don't know how to pronounce it. I don't want to be in the mood. Comes up. Your email comes up tomorrow. You're gonna have a
Susie
problem.
chooses 4 pieces of bubble gum from a jar containing 5 red, 2 blue, and 3 green pieces of bubble gum. Calculate the probability that Susie selects.
What question?
Part B.
Question.
At least one red and one.
The whole
Well,
page,
let
no
Mr.
question.
Dean warm up his brain first. So you're choosing 4 pieces of bubble gum. Okay, that's the total. How many pieces of bubble gum are there in total?
10.
Yeah, so we got 5 plus 2 plus 3 pieces. Is that 10? Yep, that's 10. So our total probability would be,
10 choose 4.
yep, our total number of selections would be 10 choose 4, and that becomes our denominator,
210.
210.
210.
Okay. Just as a recap of, if you want to see how it's calculated, it's 10 factorial over
4
4 factorial, 6 factorial. Yep. Expand the numerator up until the highest factorial in the denominator. That's 6 factorial. So that can cancel out.
Don't you get rid of 6?
Yeah. And it will cancel out.
So
I just wanted to expand it.
10 times.
Anything else you can cancel out, cancel out. So the 8 cancels out there. You can also cancel out the 3 and the 9 there. So we've got 3 times 7. The denominator is 1, yeah? 3 times 7 is 21. 21 times 10 is 210, like Anujan said. Okay? So we want no red bubble gum. So let's find the number of selections that we have. Green. No green. So we want to choose 4 pieces, right? No green bubble gum. So isn't that the same as all of them minus 1? Wait, all green bubble gum? No?
Yes. Green dash.
I just did 7
1
choose 3.
minus green.
1 minus all green, yeah? So what's the number of green? All green, huh? But, wait, hold on. That means you can still choose 3 pieces of green bubble gum, 2 pieces of green bubble gum, and 1 piece of green bubble gum, right?
Oh yeah.
No, you do 0. 3 choose 0 times the remaining, which is 7 choose 1.
Okay. So we want to choose 0 green pieces of bubble gum, right? And there's 7 pieces of bubble gum left over. And from that, we're going to choose all 4 of them. Yeah, and we don't care if it's a red or a blue, so as long as there's no green.
You say 4.
No green.
Yeah, so why is it 4? 7 choose 4.
Is there 3 bubble?
There's
bubble?
3 green bubble gum.
Yeah, but you're choosing none of them as green bubble gums.
Oh, so you have to get other one.
Yeah, and how many do you have to choose altogether? How many pieces?
4.
You have to choose 4. So how many are left over? Oh, if you choose if you don't choose 3 of them as green, well, you don't want to choose any of the greens, yeah?
Left with 7.
Yeah, so you're left with 7. So you want a red or a blue one. Yeah, so that's red or blue. So calculate this. 3 choose 0 is just 1.
And John got the answer.
7 factorial is 7 times 6 times 5 times 4 factorial. 3 times 2 times 1 times 4 factorial. The 4 factorials here are going to cancel out, like so. What else cancels out? We've got the 3 and the 2, that cancels out with the 6. We're left over with 35 combinations there. So for part A,
35 over 200.
yes, 35 over 210. Can we simplify that?
Yeah, 1 sec.
So now we're going to write it as the probability of no green is equal to no green, the number of no greens, which is 35, divided by the total outcome.
How did you get the
7
two
out of.
answers? You didn't even do that.
Oh, can't you divide this, the 35 by 7? That's 5 out of. What's 30? What's 210 divided by 7? 30. So I can divide this a bit more. It's 1/6.
Yeah.
Oh, because the pyramid.
Oh yeah. I
Yes.
know you got it, but
Because look,
so can we just skip that 3?
look.
The 3 choose 0 because it's already 1.
Yeah, I know, but I write it down for understanding.
Okay.
Yeah,
Because
to
that's,
show that we're not choosing any green.
because that's what he did. And he
No,
got confused.
No. I just 10 minus 3, which got 7 because there's 3 green bubble gums.
Mm-hmm.
So that's like 7 choose 3, and then
Mm.
that's how I got one.
7 choose 4.
I got 7 choose 3, but it's the same answer, 34.
7 choose 3. But what's
Yeah.
your logic behind it though?
No, you got 3 because 3 bubble gums comes from the stuff.
You're supposed to choose 4 bubble gums altogether instead of 3.
I still got it. I still got
Because
it.
Susie chooses 4. Yeah, but the values, like the logic is incorrect. Okay, my brain's warmed up now. We can do this part B question.
At least one.
At least one green bubble gum. Okay, so it'll
At
be
least one.
C or B? Ah, okay.
So
Sorry,
what-
we jumped to C then.
So we choose 4. At least there has to be at least one, yeah.
At least one green bubble gum.
And at least.
And at least one.
Okay, so if you've got, you need at least one green bubble gum. So out of the 3 green bubble gums, you want to choose 1. And you also want to choose 1 red bubble gum, right? There's 5 red to choose from. Let's say you choose 1. And so how many blue pieces of bubble gum will you end up choosing in this combination here? Because you got to make up 4, yeah? So this is 1 green.
Can you get 2 green, 1 red, 1 blue?
Yes. Or you mentioned 2 green,
Yeah.
1
1 red,
red.
1 blue.
Because you need at least 1, what is it, 1 red bubble gum, yeah?
There's so many.
1 green, 2 red, 1 blue.
And then you can have 3 green.
So 3
One red.
choose
Yeah.
2,
But 3 red and 1 green.
Yeah.
5 choose
So green, red,
1,
blue.
2 choose 1.
That's like
Or,
Plus 2 red, 1 green.
well, can't you choose
3 green, 1 red, yeah?
3 green, 1 red, and 0 blue?
Yeah.
Right, because this still satisfies this here.
You need 2 green, 2 red.
Hold the door. I'm slow.
Hold the fifth now. You can need 3 red and 1 green.
No, I have to do 2 red, 1 green, 1 blue.
Just 3 red, 1
What
green.
about 2 green and 2 reds?
That's
Oh yeah.
Yeah?
See?
And then 0.
3 red, 1 green.
Can't
No,
you
I'm
just
just
use
saying.
the probability of at least one green bubble gum, 1 over 6, and times it by probability of 1 red?
See if that works.
And 0 blue.
But we're doing it based off logic here, yeah? So 3 choose 2, correct? Times?
5 choose 2.
Yes.
2 choose 0.
Okay. What's one more combination?
2 red, 1 green, 1 blue.
1 green. How do you mean?
So you're going at least one green bubble gum, right?
Yeah.
One, two, three, four, five, six, seven, eight, nine, 10.
How many green bubble gums do you have? There's a cap, yeah? Oh, good.
Oh, there's one more.
Is there supposed to be
It's easy to like. Sometimes our brain goes like, "Ooh, patent, bam," right? And then we gotta like just make sure, double check, and that's where the
Is there a faster
thinking comes in.
Is there a faster way to do this?
Sorry,
Is there a faster way to do this?
I don't think so, son.
Because if there's 5 or 6, that'd be much.
I think that's it. I think
Just gotta get better.
You just this is remember these questions are more about exploration, right? It's about thinking expansively. So, yeah, it's fine if you do this question and you're like, okay, I think it's time to do another subject now. Yeah, for homework. 3 choose 1 times 5 choose 3 times 2 choose 0. Now with the choose zeros and the choose 2s, what do you know they cancel out to become?
1.
Yes. This one turns into a 1. This one turns into a 1 here. This one turns into a 1. This one turns into a 1. What about the choose ones?
Should turn into 2.
Right?
They turn into the number on top.
Yeah, they turn it into the number, the actual number itself. Oh, not that one.
Is it
5,
the same thing?
2. Sorry?
So
Five.
the first one's the same. There's
Five.
one
Yeah,
more.
it would be.
So there's one more.
Sorry?
There's
5 and
3 reds and 1 green as well.
3. 3 reds.
And 1 green.
3 reds,
Oh,
1
yeah,
green.
wait.
Yeah, that's this one here.
Oh man,
Yeah.
come on. Wait, come
Why
on,
do you have
man.
1, 2, 3, 4, 5, 6?
That's so good. What do you get 6 man? What's your first one? What's your first one?
If your number is also one number just underneath it, it also turns to the same number at the top. Because if you think about the row of 3, it's 1, 3, 3, 1, right, for Pascal's triangle. And if you're looking for position number 2, that's position number 0, C1, C0, C1, C2. The 3 there is the same as this one here.
And then you have 3 choose 3, which is 1.
Sorry?
3 choose 3.
Yes, that is equal to 1 because it's
Oh,
the same
look.
there.
2 red, 1 green, 1 blue. That's top up.
What's
yeah,
5
yeah.
choose
Yeah.
3, 5
There's
choose
another
2?
one. There's 2
Yep.
red, 1 green, 1 blue.
2 red.
1 green, 1 blue.
5 times 4.
Oh yeah, there is.
2.
Oh my days.
This has to be at least 1 green. It has to be at least green. 1
At
green,
least 1 green, 1 red, and 1 green. At
Oh.
least.
Yeah, 2 red, 1 green, 1 blue. I think.
Yeah, we've got one more. You mentioned?
2 red, 1 green.
1 blue.
1
Oops.
blue. Yeah, 5 green, 1 blue.
1 green, 2 red,
So, we
1
can-
blue.
Daniel, these questions is long.
Yeah.
3 choose 1 times 5 choose 2 times 2 choose 1. Okay. 3, 2. What's 5 choose 2 and 5 choose 3? We haven't done these ones yet.
3 is 4 times 10.
10?
Five,
Yep.
choose
Or you can think 1, 5, 10, 10, 5, 1, 0, 1, 2, 3. Yep.
Nice. 10 still. Yeah?
10. 10. 10.
So
Oh.
3 times 5, 15,
Yep. Let's go. 15 plus
30,
30
45,
plus.
130.
45,
80.
50,
60.
120, 170.
How did you get from 120 to 170?
Huh?
How'd you get from 120 to
Is that the answer you got?
160.
Yeah.
Or have we missed one?
No.
I'm getting the 17.
Sorry?
Now 110 plus
It
60.
says 17 over 1.
17.
10 plus
17.
Yeah, because that's the number there.
I tried a different
And then our total is. Yeah, what was your different method?
I don't know. I'm getting a negative. It's correct, but it's negative.
1 minus 38 over 21. Why'd you choose 38 over 21?
It's in the square box.
Mm-hmm. 5 over 6.
What's the difference between you and mine?
Because of no green.
So this is yours, yeah?
Right, no green and no red, yeah?
Mine is lighter for some reason.
Okay.
Mine's
I'll-
green,
What's the probability? Okay, so we ended up with at least one green and at least one red, yeah?
So these are the ones.
That's 170 over 210. That's 17 over 21. But let's see what it would be if we did 1 minus the probability of the fact that we choose no green and no red. 0 green, 0 red. So how do we calculate the number for 0 green, 0 red? What do we have? We had 3 greens, we're choosing none of them. We have
5 red, choosing
5 reds, we're choosing none of them, and
2, choose 2.
2 choose, but you need to end up 4, yeah? That's not possible, so you go 2 choose 2. But you still here, you still have to calculate out your different ways of picking out a red or a green, yeah? You still have to calculate. So this one here wouldn't work. Question. How many greens and reds are there together?
8, yeah? 10?
8.
There's 8, isn't there?
Oh, without blue, yeah, let's see.
Yeah, without blue there's 8. So I want to see if we can look at this from a different perspective here.
How many reds and greens do you have?
So red
8.
and green, we have a total of 8. So we need at least 1 red and 1 green, right? So we're at least choosing, we got 8, we're choosing 2 of them, right? And so if we have 2, then we choose 2 there. So we make a total of 4. Or we have 8, choose 3. And for the blues, we choose 1. Or you can go 8, choose 4, times 2, choose none. For the blues, yeah? Blue, 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 and this one's red or green. Oh, whoops. My gosh. Green or red, yeah? Because we can group the green or red together. Isn't that true? But since you have to choose at least one, can you figure out what this is? Is it Kaz?
Yeah.
That's 1, that's
Well, I
2,
thought it was mine.
that's 1. Isn't that another way to look at it? No? I might be wrong.
I think for understanding the other one.
That equals 210.
Let me just double check, you know.
But I think the other one is better for understanding.
Yeah, the other
Yeah,
one's
other
better.
for, yeah, understanding.
This one here, although it's tedious, it's better for understanding because you're actually looking at all the different outcomes.
Yeah, it gives 210.
Put water. Water. Yes, you can put water on your face. In other words,
Wash my face, that was the word.
you can wash your face. Yes.
So how do
It's
you get
incorrect.
210?
Sorry?
210.
Oh, that's 210. That's a pity.
How much time do you have left? What we supposed to do chapter 11b?
I don't know. Sure.
But then we know
154. Can I have a look?
What should we roll by? 152.
NCI, choose to. I would just do. No, that's equal to 1.
We're gonna do
No, that's equal to 1.
What's what you gonna do?
Yeah,
Oh,
it
no,
should
I
be
think it's
equal
damage.
to. Wait, hold on.
I like Robinson.
Oh,
I like Robinson.
You like what
you
we
didn't
played?
do 8 choose 3.
It is good. Yeah, it's 210.
What's what we played?
It is good. Like volleyball, hockey.
Yeah, it is 210.
Play soccer.
Yeah, something.
Ah, this is wrong.
Basketball.
No, it's a class.
Volleyball.
Why is that wrong?
No. It gives the total outcomes.
Yeah. Well, let's look at the logic here.
Calculate the probability, not the outcomes.
Do you know why? Because when you choose 3 here, it doesn't specify if you're choosing 3 of the... You could, here, when you choose 3, you could choose 3 greens and no reds. That's the problem there. Yeah, so here you would actually have to split it, break it down, because here that means that you could do choosing 3 greens and 0 reds, but it did say that you wanted at least 1, yeah? At least 1 red as well.
If you break it down, is it going to go back to the same method you did before?
Yeah, if you break that further down, yeah, it would go back to this method here. So this, although we thought the problem with this is that not specific
What is
enough.
this? Wait, who was Isaac?
Oh no, how? My bad.
Who was?
My bad.
Need to split into green and red.
You need that.
Does that make sense? Oh my goodness. Alright,
So go back to that.
I'll just stick with the other one.
Yeah, same.
shall we go back to this? Sampling without replacement with
17 minutes.
17 minutes on the clock.
Yeah, let me.
Sorry? 11A. Why?
Some refreshing, you know?
Yeah? More refreshing? Nah.
No, there's a question there. But we can do that later. Let's start with the one.
Yeah, we'll get started on this one here, okay? Now, you know that with sampling without replacement, the total number of your value there, every time when you pick out an item, you leave it out, or let's say you eat it, which means you can't put it back in, yeah? The total outcome, or the total number that you're choosing from, decreases by 1 with each stage of your experiment. Okay?
If you call that what? You call this probability?
Sorry?
Without replacement.
Yeah.
Yeah, it's right there, man.
It's right there.
Yeah.
That's right.
When an object is selected from a finite group of objects and not replaced before a subsequent selection is made. Yep. The effect of this is that the probability of observing a particular outcome changes after each selection. So it does change based on what you pick. Yeah, you can see here the probability for picking a toffee for each in the second selection is different, yeah, depending on what you pick first. So is this dependent or independent events? It is dependent, which means it relies on what actually happens before, okay? So I'm just going to go through here and say, okay, we can still focus on this x. So when it says x here, what are we trying to find first? What that definition is, yeah? Can you find, and it's in the section that I've just kind of like put on the screen there, what the variable x is defined as?
X is the number of mints he selects,
Okay.
which can take out 0 and 6. It says right there.
Yep. The random variable x is the number. No, so I'm just going to say x is the number of mints he selects. So it can take the variables or the values of 0, 1, and 2. So what I like to do is I like to write that out on the side. Yeah, x equals to the number of mints. And these 0, 1, 2s are the values. So remember they're discrete values. That's why I use curly brackets, and it's a lowercase because they are those individual values there. Okay.
Yeah,
I like to write that out as a preface. Yeah. Every time when you come across a particular worded question. Okay. You can see here when you're looking for one mint, you still have to go looking and observing for the branches. Then you have to multiply them, then add them together. Okay? This is a pain. Yeah? This is a pain. So is there a better way to do this? Like we can still get out the probability distribution table. It says here, in chapter 10, we use NCR to denote the number of combinations that with n objects and a group size of R. In this chapter, we're going to use the alternative notation. So instead of writing NCR anymore, we're going to write it as 2 brackets with an N and the R on the bottom. Okay, it means the same thing, except now when we start doing the calculations, it's a bit easier for us to write, yeah? Because we don't want to keep on writing the C, the C, the C. Okay?
You were close to
So it says here, first consider the situation x equals 0, or the number of mints is equal to 0, so we're not choosing any mints. Yep, 2 lollies, none of them are mints. Then it must contain 2 toffees. Okay, so notice here how you only have 2 options. You either pick a mint or a toffee, yeah? So if you're choosing 0 mints, that's 3 mints. Out of the 3 mints, you're choosing none of them. That means out of the 4 toffees, you're choosing 2 of them. Yes? Your total outcome is that there's 7 lollies in the bag altogether, and you're choosing 2 of the lollies. So the combinations here, when you do combinations, right? And this is something that we've already been doing so far. Okay? This here takes into consideration that you've selected and you're not putting it back. Okay? So the combinations does all the hard lifting for you here. How you have to go and calculate each individual branch. Does that make sense? So the technology is a bit more advanced. So you can see if you want 1 mint, that means out of the 2 lollies that you're picking, out of the 3 mints, you're definitely going to choose 1. And then out of the 4 toffees, you're definitely going to choose 1. It will work itself out. Okay? Let's try this one here. I know the answer's there and you probably already looked at it, but that's okay. Does anyone have a headache?
So the heater.
Yeah, should we turn off the heater?
Yes, please.
See if I can actually even get there.
No, almost like that then.
Okay.
It's sunny now.
Yeah, now it's
sunny
sunny.
now.
Wow.
Oh, now it's not sunny.
Interesting. Marine biologists are studying a group of dolphins which live in a small bay. They know that there are 12 dolphins in the group, 4 of which that have been caught, tagged and released to mix back into the population. If the researchers return the following week and catch another group of 3 dolphins, what is the probability that 2 of these will already be tagged? Ooh, that's a lot. of questions. Yeah? Let's break this down. How many dolphins do you have altogether?
12.
Okay, 12.
Oh, they caught
Four
them,
have
then
been
they tag
caught.
them, and
Mhm.
then release them.
Then they
right?
eat them. No. Then they put them back, yes.
Yeah.
So, what kind of dolphins are we looking at here? What are the two options?
Dolphins which are normal and dolphins that are tagged.
Okay.
4 which are tagged, 8 that are not tagged.
Yeah.
So you're looking at tagged and not tagged, yeah? Or tagged and not, or T dash.
Yeah, two.
We can do that.
They are doing that as well.
So second time you come around, T and T dash, T and T dash, yeah?
Then again, one more time.
The following week,
Group of 3 dolphins.
what is the probability that two of these will already be tagged? So instead of saying the word catch, what word could you use that we're familiar with in terms of this concept?
Tags.
Nope. Anne said it.
Choose.
Yes.
What?
Choose.
Choose.
Oh, choose, okay.
To catch means to choose, yeah? You don't know which one you're choosing from, but you are choosing it. Before you even catch him, you just tag him, yeah? Boom! So, out of the 12 dolphins, you know that this is the number of tagged dolphins, yeah?
One more line.
Yeah.
I don't know. You answer. You make it.
Huh?
Yeah, what it was.
Oh yeah, I have business.
Hmm.
Yeah, period 3. No, period 2.
If the researchers come back the following week and catch another group of 3 dolphins, so if they choose another 3, so they choose 4, then they choose 3. Hmm. Yeah. But in the following week, they come back and choose those 3 dolphins. Interesting. Four tagged. 4 out of 12 tagged.
There should be 1 out of 6.
And then there's 8 out of... Sorry?
There should be 1 out of 6.
Why 1 out of 6?
Catch another group of 3
Why?
or 3
You
dolphins.
cheat.
Yeah.
We have to find them. We don't want to cheat.
It's not cheating, it's a video.
We have to use your mind.
There should be 1 in 4 times.
And then, so it's gonna be 3, 11.
1 over 24.
The second one? Yeah, 3.
Oh, do they tag the 3 dolphins that they're choosing from?
No, they're choosing.
No, they choose 3 dolphins.
Yeah.
3 choose 2. 2 of them win.
Mm.
So wait, they 11, 12 dolphins. So 4 of them have been tagged.
4 of them have been tagged out of the 12,
and then,
yeah?
Then all of them are released,
Yep.
and then you choose 3 out of these 12. And what is the point of them?
So isn't that the total outcome?
What is the problem? We're trying to find the PR of 3 choose 2.
It's 12 over 3.
Yeah.
So,
12 over 3. Isn't it the same thing?
Why 4? Why 12 choose 4?
because there's 12 dolphins in the group and they caught 4 of them. Is it 3 choose 2 divided by 12 choose 4?
Choose 3.
No, here it says
12 choose 3.
12 choose 3 instead of 12 choose 4.
12
Sample
choose
size of
3.
so
Oh, well,
Oh, it's because a sample size of 3 is so that from the
Yeah, not
population of
choosing.
12.
yeah. So, out of the 12, you still choose the 3. But would you multiply it by... That's the number
On
of
the
dolphins,
bottom,
yeah?
On the bottom 12 choose 3.
Oh,
Yeah.
why is that?
And then on top is 4 choose
Because out of
2.
the 12, you're choosing
open bracket, close bracket.
Oh, wait, hold on. Yeah, the probability. No, wait, okay. Yeah, so you 12 choose 3, because you choose 3 dolphins out of the 12, right?
Yeah. And what is it?
And we know that
And what does the 4 choose 2 mean?
out of the 4,
There's
there's 4 dolphins. You could choose 2 of them,
Not so.
but
And then one of them is not tagged.
one of them, which is the rest of the 8, they're not tagged. Or you can choose.
That's it. You don't
That's it. You don't need to calculate the other probabilities, yeah?
that's in the textbook, yeah.
Okay.
Does the 4 choose 2 mean? What does the 4 choose 2 mean? I don't understand the top part.
Okay. So let me explain here. These ones are tagged, yeah?
Yeah.
Those 4 dolphins are tagged, whereas the other 8 dolphins are not tagged. If you're just focusing on choosing 2 of them being tagged, then you're choosing from those 4. That's your desired outcome, yeah?
Yeah.
And if you're only choosing 2 of them out of the 3,
And so what is left?
so yeah, whatever's left is 8. You're gonna pick one of them that's not tagged
Okay.
because it's asking about the probability. Yeah. And so notice here that
Yeah.
Outcomes.
the top part adds up to each other. The bottom part adds to each other. So if you write it in the other notation, it's 4 choose 2 times 8 choose 1
Over.
over 12 choose 3.
Equals 2 and then base 2. So they have to add up to each other.
Oh yeah. What do you want?
So you have 0 plus 2 is 3 and then base 2 at the bottom. So it'll be added.
Hey, how are you?
Good. You want to get rid of it?
I haven't checked it all day.
Thank you. Thanks for helping.
Student's phone?
Sorry?
Student's phone?
Yeah, confiscation. It's my phone. It's been confiscated. Sorry?
Does the top part always add up to the bottom part?
Yes. Sums to 12. And the bottom one sums to 3. Saban?
Oh yeah.
You can run that calculation, and that's the probability. Wait, let's go. Let x equal to the number. I think it would be easier if we defined it, yeah? Let x be the number of tagged dolphins, yeah? Chosen from 3 dolphins. So how many dolphins can you choose that are tagged? You can choose none of them that are tagged. You can choose one of them that are tagged, 2 of them, or 3 of them that are tagged, yeah? And the question's asking us when the probability that the number of tagged dolphins is equal to 2.
Oh, and then, yeah.
Yes. Okay.
That's the example.
Let's go home and sleep, everybody. Good night.
You spend 110